Okay, is it visible to all of you? Hello?
No, sir, it is not visible, sir. It shows
Not
that
completely visible. White screen is visible, sir.
white screen is visible. Okay.
Yes, sir. Screen is visible.
Is this screen is visible or not?
Yes, sir. Yes, sir. Screen is
Visible?
Yes, sir.
Sir, only white screen is visible, nothing else.
Only white screen is there, sir.
आ नहीं रहा ना स्क्रीन? अभी तो चल रहा था, अभी हमने जस्ट उसके पहले चेक किया था। रुकिए, देखिए फिर से आ रहा है। नहीं, अभी भी हमने चेक किया था 2 बजे, तो एकदम स्क्रीन एप्लीकेशन विंडो इसमें अभी ओपन ही नहीं हो रही। रीस्टार्ट करके देखता हूँ मैं एक बार फिर से। हमको लग रहा है कि टीम वाले को रीस्टार्ट करना पड़ेगा। ठीक है।
Yes, sir. Your screen is PPT is visible now. Thank you, sir.
Now I am audible also?
Yes, sir. You are audible.
Okay, okay. Then we can start. It has taken 10 minutes. So let us start. First, Internet of Things. I think all of we are teachers and we have already heard these terms from last 10 or 20 years. So this is nothing new.
Sir, sorry to interrupt you. Sir, your PPT is again not visible. Yes, sir. Now it is visible. Please, yes. Thank you.
Okay. I am audible also?
Yes, sir. You are audible and PPT is visible.
Okay. So I think we all are faculty members and we have heard about Internet of Things number of times. And we know many of things which we are already using, but we do not consider it as a part of the Internet of Things. So normally, when we talk about Internet of Things, what is Internet of Things? This is not a topic of technical significance only, but it has the capability of transforming the social as well as economic scenario altogether. So first, when Internet of Things come in the mind, the phrase Internet of Things was first coined by Kevin Ashton in the year 1990. He was writing an article for the RFID journal where Mr. Ashton wrote, if we had computers that knew everything there was to know about things using data they gathered without any help from us, then we would be able to track and count everything and greatly reduce waste, loss, and cost. We would know when things needed replacing, repairing, or recalling, and whether they were fresh or past their best. We need to empower computers with their own means of gathering information so they can see, hear, and smell the world of themselves in all its random glory. RFID and sensor technology enables computers to observe, identify, and understand the world without the limitations of human entered data. This was way back in 1990. We have come long way from this and from RFID to many more connectivity technologies which enables and helps in realizing these things in a better way. So this slide simply depicts how the evolution of Internet of Things was. First, pre-internet, there was human-to-human interaction. There was fixed and mobile telephony, SMS, and after that comes some smart networks When we add some smart networks, then it becomes Internet of content and comes www. We start emailing information, entertainment, etc. And after the adding some more smartness to this by adding IT platforms and services, we entered in the era of Web 2.0, where e-commerce, e-productivity, and internet services comes in the picture. We continuously evolving, and by using smartphones and their applications, people becomes more interactive and started to treating world as a simple global village. A person sitting in India can have contact, talk, or sharing with other person or another person sitting in way away in America, Europe, or other countries. Skype, Facebook, YouTube, these social media technologies help people to come closer. And with some more advancement, we added more technologies enhancement such that machines started to talk with each other, which we take M2M technology or Internet of Things. Sometimes M2M and Internet of Things used interchangeably. The use of Internet of Things is in many domains of the human life. Is the medical, in agriculture, in industry. We can say there are a number of field or area where machine to machine communication takes place and machine to human interaction takes place. So when there are number of areas, then how these communication takes place? There must be some protocols or set of rules by which these diversified machines and data will be communicated to each other. So when we are talking about IoT, it is the most of the times about networking of the physical objects. These physical objects are embedded, sense, and interact with internal state or with the external environment in which they are operating. So how these objects communicate with each other? There must be some technology or devices. So for communication purpose, these IoT devices are equipped with embedded sensors, actuators, processors, and transceivers. Therefore, IoT is not a single technology. Rather, it is an agglomeration of various technologies that work together in tandem. Sensors and actuators are devices which help in interacting with the physical environment. The data collected by the sensors has to be stored and processed intelligently in order to derive useful interference from it. It is not only the simple collection of data. If we cannot inference from this collected data, then it is useless. That's why there are a number of technologies come and gone, where we can able to collect data, but unable to draw inference from them. I think I will, if time permit, then discuss some of the technologies. Note that we broadly define the term sensor. A mobile phone or even a microwave oven can count as a sensor as long as it is provides input about its current state. Current state means internal state plus environment behavior. While an actuator is a device that is used to affect a change in the environment, such as the temperature controller of an air conditioner. We can say that temperature controller is also an actuator. So either communicating with each other, they change their different states, or they are interacting with the external environment in which they are working. As I have already said, sometimes M2M, that's why sometimes M2M and IoT are used interchangeably. But both are not the same. Is there is problem in the audio? Is I am audible?
Audible. Yes, sir, you are audible.
Okay, thanks. Because there is some disturbance in my side. I think disturbance in the other side which comes. So there are some fundamental difference. I think someone's audio is on. So please mute your audio. There are some fundamental differences between them. M2M. There is disturbance from the other side. UP Singh ji, please see. There is disturbance.
Every
So that I
participant is
think,
requested to please mute your mic.
yes, I think someone's mic is remains on. Please off it or mute it. So I think if I am audible, I can continue. The basic
Sir, you
idea of
are
IoT
audible.
is the
Yes, sir, you are audible.
okay. The basic idea of the IoT is the pervasive presence of objects, which with unique addressing schemes. Please analyze which with unique addressing schemes, because unless it is unique, no one can inference from where the data is coming. So the unique addressing scheme is needed, can interact with each other and cooperate with their neighbors to achieve common goals. Therefore, almost all the everyday objects combined with internet connectivity with powerful data analytic capabilities promise to transform the way we go about our daily business. So that's what we want to achieve from Internet of Things. Already we have started and see number of applications of IoT in our daily life, be it a public or private sector or any ordinary consumer. It ranging from operation, industry, it is in elements of building, retail entities, transportation, IT networks, to the level of research. The sum of the core areas where IoT can play an important roles are, I am simply summarize this. I am not going to discuss because the talk is on the connectivity technologies. I am simply summarizing this. IoT applications areas. These are consumers, whether it is in smart home control, maintenance, smart energy use, or it is in medical use, such as telemedicines, implanted devices, wearable devices, or it is in military use, where threat analysis can be accessed, troop monitoring can be done, or resource allocations depending on the area where troops are placed, or it is automotive in a industry where parking, anti-theft locations, traffic flow. I am only, this is not the thing only where we can use it. It is only simply to show that in all domain of the lives, we are using the IoT, and it is already applicable and used in these areas. I am only mentioning some of them, such as in the industrial, smart meters, manufacturing control, warehouse sensing. Industry, now we have talked about industry 4.0. It is basically the technology-driven industrial production process. We can discuss, you can find number of lectures and materials on net. Also, it is not limited to industry, it is also used for environmental control, such as species tracking, resource management, weather forecasting, in agriculture, crops management, soil analysis, or in retail, inventory control, focused marketing, product tracking, etc. So, I have tried to communicate that IoT, what is IoT, and where it is applicable. Then next come how we are from a technology point of view, how different devices communicate with each other. What are the different methods? What are the different technologies which helps to different devices to communicate with each other? And from the data processing techniques, etc., from where we draw the references and take the decisions and implement them. So basically, 4 primary communication models are used to allow IoT devices to communicate. These are device-to-device communications, device-to-cloud communication, device-to-gateway model, and back-end data sharing model. I will take some time before explaining these 4 communicating models. So, how these devices are communicated? What are the challenges involved when they are going to communicate with each other? Because with the growing of IoT, there are large number of heterogeneous smart devices connecting to the internet. And most of the IoT devices are battery powered with minimal compute and storage resources. They have not the computing and storage resources embedded on them. It can be done externally. Because of their constrained nature, there are various communication challenges involved, which are as follows. First, addressing and identification. Since millions of smart things will be connected to the internet, they will have to be identified through a unique address on the basis of which they communicate with each other. For this, we need a large addressing space and a unique address for each smart object. First is addressing and identification. Second is low power communication. Communication of the data between these small devices is a power consuming task, especially when we talk about wireless communication. Therefore, we need a solution that facilitates communication with low power consumption. Third, routing protocols with low memory requirements and efficient communication patterns. Fourth, high speed and non-lossy communication. And fifth is the mobility of a smart SIM. Therefore, considering these communication challenges, these four models are proposed. One is device-to-device communication, other is device-to-cloud communication, other is device-to-gateway model, and fourth is back-end data sharing model. And using these four models, we use lot of existing communication protocols which fit in the framework of these four communication models. So we will see them one by one. What is device-to-device communication? In the device-to-device communication model, I am simply given the definition here. You can see and read. In device-to-device communication model, the two or more devices connected directly, and communication occurs among them over different types of networks, including IP networks, using a particular communication protocol without any intermediary server to realize their functionality. This communication model is employed in applications where the information to be exchanged between devices is small with relatively low data rate. Second is device to cloud communication. In a device to cloud communication model, the IoT device connects to a web cloud service like an application service supplier to exchange information and control message traffic. In this model, the existing communication mechanism is useful in establishing a connection between the device and IP network that ultimately connects to the cloud service. But, however, interoperability challenges can arise in this model if proprietary data protocols are used between the device and the cloud service. So one has to take care of this if he is using the device to cloud communication model. Next is device to gateway model. In a device to gateway model, or more precisely device to application layer gateway model, the IoT devices connects through an ALG service as a medium to arrive at a cloud service. This model implies an application software performing on a local gateway device. This application software serves as an interface between the device and the cloud service. And also it provides security and other functionality such as data protocol translation. And the fourth model, proposed model, is back-end data sharing model. The back-end data sharing model is an extension of single device to cloud communication model, which facilitates user to export and analyze smart object information from a cloud service in a cooperation with information from alternate sources. In this communication model, users have the flexibility of granting access to upload sensors data to the third parties. Also, a backend sharing design permits data collected from single IoT device data streams to be aggregated and analyzed. The backend data sharing model suggests a unified cloud service approach or cloud application coders interfaces. Square measures required to realize the ability of small device information hosted within the cloud. Among these four models, the use of any of these models largely depends on the proprietary versus open nature of the IoT devices being networked. From end user point of view, these four communication models open possibilities of using the information in a new way by the use of data aggregation, data visualization, data analytics, etc. So, IoT devices in this slide, I simply put some of the leading communication technologies used in the IoT world, that is IEEE 802.15.4 wireless HOT, which is basically used in instrumentation, low power Wi-Fi, low wide pan area network, Sigfox, NFC, RFID, LoRaWAN, Zigbee, Bluetooth, XMPP, MQTT, and many more other proprietary protocols for wireless networks. It is not limited to only these number of protocols. There are a number of protocols which can be used with some modification so that they consume less power and with some storage or data processing capabilities can be used in IoT communication. I am take this slide from the course on Internet of Things of NPTEL, simply for the purpose of that IoT protocols can also be organized on the basis of their functionality. That is, on the basis of connectivity, on the basis of identification, on the basis of communication or transport, on the basis of discovery, on the basis of data protocols, on the basis of device management, or semantic or multi-layer framework. For example, for communication or transport purpose, there are Wi-Fi, Bluetooth, low power wide area network, LPWAN. For data protocols, there is MQTT, etc. So, before covering some of these for this session, because it is not possible to cover and explain all of these protocols in a single lecture, I will try to cover in such a way that on the basis of functionality or functionality as well as on different technologies, we can cover at least 4 or 5 or 6 protocols and try to compare them on the definite parameters so that if anyone is interested in research, they have some idea how they can proceed in that direction. So in this, I will simply take on functionality basis some connectivity protocols, some communication or transport protocols, and data protocols. So before we start this, we can say how these devices are communicated. IoT devices are typically connected to the internet through the IP stack or internet protocol stack. This stack is very complex and demands a large amount of power and memory from the connecting device. The IoT devices can also connect locally through non-IP networks, which consume less power and connect to the internet via a smart gateway. Non-IP communication channels such as Bluetooth, RFID, and NFC are fairly popular but are limited in their range up to few meters. Therefore, their applications are limited to a small personal area network. Personal area network or PAN are being widely used in the IoT applications such as wearable connect to smartphones. For increasing the range of such local networks, there was a need to modify the IP stack so as to facilitate low power communication using the IP stack. One of the solution is six low WPAN, means 6 low wide personal area network, which incorporates IPv6 with low power personal area network. The range of PAN with 6 low WPAN is similar to the local area networks and the power consumption is much lower. So it is one of the technology which is widely used in IoT. The leading communication technologies, as this slide shows, used in the IoT words are IEEE 802.15.4, low power Wi-Fi, 6 low PAN, RFID, NFC, Sigfox, LoRaWAN, and other proprietary protocols. So let us start with near field communication. Near field communication is a very short range wireless communication technology through which mobile devices can interact with each other over a distance of few centimeters only. All types of data can be transferred between two NFC-enabled devices in seconds by bringing them close to each other. This technology is based on RFID. It uses variations in the magnetic field to communicate data between two NFC-enabled devices. NFC operates over a frequency band of 13.56 megahertz, which is the same as the high frequency RFID. There are two modes of communication or operation, that is active mode and passive mode. In the active mode, both the devices generate magnetic fields, while in the passive mode, only one device generates the field and other use load modulation to transfer the data. The passive mode is useful in battery powered devices to optimize energy use. One benefit of the requirement of close proximity between devices is that it is useful for secure transactions such as payments. NFC can be used for two-way communication, unlike RFID. That's why almost all smartphones in the market today are NFC enabled. As this slide shows, in this slide I summarize the NFC using different characteristics and the same parameters I have taken for all the technology I have discussed in this session, going to discuss in this session, so that if anyone want to work on any one of the technology, he has some ground so that he can compare different technologies and starts his work. That is standards, frequency band, network, topology, power. It uses power of 15 milliampere, that is very low power. Data rates, what is the range, security, which type of security is employed by the NFC, spreading, which type of modulation it is using. For example, NFC is using ASK modulation and features. So next is RFID, because it is RFID and NFC are similar. So it is logical to discuss RFID just after the NFC. So what is RFID? RFID is an identification technology in which an RFID tag, which is a small chip with an antenna, carries data, which is read by a RFID reader. The tag transmits the data stored in it via radio waves. It is similar to the barcode technology, but unlike a traditional barcode, it does not require line of sight communication between the tag and the reader, and can identify itself from a distance even without a human operator. The range of RFID varies with the frequency. It can go up to hundreds of meters. RFID tags are also of two types, active and passive. Active tags have a power source and passive tags do not have any power source. Passive tags draw power from the electromagnetic waves emitted by the reader and are thus cheap and have a long lifetime. Also, there are two types of RFID technologies, near and far. A near RFID reader uses a coil through which we pass alternating current and generate a magnetic field. The tag has a smaller coil which generates a potential due to ambient change in the magnetic field. This voltage is then coupled with a capacitor to accumulate a charge, which then powers up the tag chip. The tag then produces a small magnetic field that encodes the signal to be transmitted, and this can be picked up by the reader. While for RFID, there is a dipole antenna in the reader, which propagates electromagnetic waves. The tag also has a dipole antenna on which an alternating potential difference appears, and it is powered up. It can then use this power to transmit messages. RFID technology is being used in a various applications such as supply chain management, access control, identify, authentication, and object tracking. The RFID tag is attached to the object to be tracked, and the reader detects and records its presence when the object passes by it. In this manner, object's movement can be tracked, and RFID can serve as a search engine for smart things. The low-level data collected from the RFID tags can be transformed into higher-level insights in IoT applications. There are many user-level tools available in which all the data collected by particular RFID readers and data associated with the RFID tags can be managed. This high-level data can be used to draw inferences and take further action. So, this is all about RFID. The same parameters or same characteristics which I used to define NFC is used to define the RFID, that is standard frequency band, networks, topology, power, data rate, range, security, spreading, modulation type, and features. So please look at this slide so that I can further move to the next technology. That is IoT network protocol stack. Because the previous two technologies which we have discussed, RFID and NFC, has limitation because the range is very small. So they cannot be used in many applications where a large area needs to be monitored through many sensors nodes deployed in diverse locations. In that case, a wireless sensor network consists of thousands of sensor nodes connected using wireless technologies to be used. These wireless sensor network having thousands of sensors collect data about the environment and communicate it to the gateway devices that relay the information to the cloud over the internet. The communication between nodes in a WSN may be direct or multi-hop. The sensor nodes are of a constant nature, but gateways nodes have sufficient power and processing resources. The popular network technologies used in a WSN or a star are a star, a mesh, and a hybrid network. Most of the communication in wireless sensor network is based on the IEEE 802.15.4 standard. So there are clearly a lot of protocols that can be used in IoT scenarios. In this talk, we will discuss typical IoT network protocol stack with some of the most popular alternatives. For this, the Internet Engineering Task Force, that is IETF, has developed alternative protocols for communication between IoT devices using IP, because IP is a flexible and reliable standard. Also, the Internet Protocol for Smart Objects Alliance has published various white papers describing alternative protocols and standards for the layers of the IP stack, and an additional adoption layer which is used for communication between smart objects. The most of the materials I have taken from these white papers. So first is physical and MAC layer, IEEE 802.15.4. The IEEE 802.15.4 protocol designed for enabling communication between compact and inexpensive low power enabled embedded devices that needs a long battery life. It defines standard and protocols for the physical and link layer of the IP stack. It supports low power communication along with low cost and short range communication. In the case of such resource constrained environments, we need a small frame size, low bandwidth, and low transmit power. The transmission requires a very little power, which is only 1% of that used in Wi-Fi or cellular networks. This is the main advantage. This limits the range of communication. Because of the limited range, the device has to operate cooperatively in order to enable multi-hop routing over longer distances. As a result, the packet size is limited to 127 bytes only, and the rate of communication is limited to 250 kbps. The coding scheme in IEEE 802.15.4 has built-in redundancy, which makes the communication robust, allows us to detect losses, and enables the retransmission of the lost packets. The protocols also support short 16-bit link addresses to decrease the size of the header, communication overheads, and memory requirements. Next is adoption layer. IPv6 is considered the best protocol for communication in the IoT domain because of its scalability and stability. Although initially such bulky IP protocols were not thought to be suitable for communication in the scenario with low power wireless link such as 802.15.4. 6 low PAN an acronym for IPv6 over low power wireless personal data networks. Is a very popular standard for wireless communication. It enables communication using IPv6 over the IEEE 802.15.4 protocol. This standard defines an adoption layer between the 802.15.4 link layer and the transport layer. 6 low-PAN devices can communicate with all other IP-based devices The choice of IPv6 is because of large addressing space available in the IPv6. 6 low PAN networks connect to the internet via a gateway, that is Wi-Fi or Ethernet, which also has protocol support for conversion between IPv4 and IPv6. As today's deployed internet is mostly IPv4. IPv6 headers are not small enough to fit with the small 127 by MTU of the 802.15.4 standard. Hence, squeezing and fragmenting the packets to carry only the essential information is an optimization that the adoption layer performs. Especially the adoption layer performs the following 3 optimizations in the order to reduce communication overhead: header compression, fragmentation, and link layer forwarding. I can discuss this in detail, but as it is already 1 hour, so I will move forward and go to the next protocol. That is network layer stack. The network layer is responsible for routing the packets received from the transport layer. The IETF routing over low power logic networks working group has developed a routing protocol for low power and lossy networks. For such networks, RTL is an open routing protocol based on distance vectors. It describes how a destination-oriented directed acyclic graph is built with the nodes after they exchange distance vectors. A set of constraints and an objective function is used to build the graph with the best path. The objective function and constraints may differ with respect to their requirements. For example, the constraints can be to avoid battery power nodes or to prefer encrypted links. The objective functions can aim to minimize the latency are the expected number of packets that needs to be sent. Next is transport layer. I am not discussing the detail how we are draw the graphs or how we going to make this graph. If anyone interested, I can send him my slides as well as my notes so that they can familiarize themselves with these technologies and how these graphs are drawn. Next is transport layer. As we all know, TCP is not a good option for communication in a low power environment, as it has a large overhead owing to the fact that it is a connection oriented protocol. Therefore, UDP is preferred because it is a connectionless protocol and has low overhead. And next is application layer. The application layer is responsible for data formatting and presentation. The application layer in the internet is typically based on the HTTP. However, HTTP is not suitable in resource constrained environment because it is a fairly verbose in nature and thus incurs a large parsing overhead. Therefore, many alternate protocols has been developed for IoT environments such as Constraint Application Protocol, COAP, and MQTT, Message Queue Telemetry Transport Protocol. Constraint Application Protocol can be thought of as an alternative to HTTP. It is used in most IoT applications. Unlike HTTP, it incorporates optimization of constraint application environments. It uses the efficient XML interchanges, that is EXI data format, which is a binary data format and is far more efficient in terms of space as compared to plain text HTML or the XML. Other supported features are built-in header compression, resource discovery, auto configuration, asynchronous message exchange, congestion control, and support for multicast messages. There are 4 types of messages in Constraint Application Protocol. That is non-conformable, conformable, reset, and acknowledgement. For reliable transmission over UDP, conformable messages are to be used. The response can be piggybacked in the acknowledgement itself. Furthermore, it uses datagram transport layer security, DTLS, for security purposes. And other is message queue telemetry transport, that is MQTT, is a publish subscribe protocol that runs over TCP. It was developed by the IBM primarily as a client server protocol. The clients are publishers or subscribers, and the server acts as a broker to which clients connect through TCP. Clients can publish or subscribe to it. MQTT is a lightweight protocol which makes it suitable for IoT applications. But because of the fact that it runs over TCP, it cannot be used with all types of IoT applications. Moreover, it uses text for topic names, which increases its overhead. Other version of MQTT, that is MQTTS and MQTT-SN, which is an extension of MQTT, is designed for low power and low cost devices. So this is all regarding IoT network protocol stack and the different protocols used at different layers. Now we will move further and discuss the next protocol, that is Bluetooth low energy, or this is also known as Bluetooth low energy or Bluetooth Smart, developed by Bluetooth Special Interest Group. It has a relatively shorter range and consumes low energy as compared to competing protocols. The Bluetooth enabled or Bluetooth Smart protocol stack is similar to the stack used in the classic Bluetooth technology. It has two parts, controller and host. The physical and link layer are implemented in the controller. The controller is typically a SoC, that is system on chip with a radio. The functionality of upper layers are included in the host. Bluetooth Smart is not compatible with classic Bluetooth. The main difference between the Bluetooth and Bluetooth low energy, that is classic Bluetooth Smart, is that Bluetooth Smart does not support data streaming. Instead, it supports quick transfer of small packets of data with a data rate of 1 Mbps. There are two types of devices in BLE, that is master and slave. The master acts as a central device that connects to various slaves. Let us consider an IoT scenario where a phone or PC serves as the master and the mobile devices such as a thermostat, fitness tracker, smartwatch, or any monitoring device act as a slaves. In such cases, slaves must be very power efficient. Therefore, to save energy, slaves are by default in sleep mode and wake up periodically to receive packets from the master. While in classic Bluetooth, the connection is on all the time, even if no data transfer is going on. Additionally, it supports 79 data channels, that is 1 megahertz channel bandwidth, and a data rate of 1 million symbols per second. Whereas Bluetooth Smart or BLE supports 40 channels with 2 megahertz channel bandwidth, that is double of classic bandwidth, and 1 million symbols per second data rate. BLE supports low duty cycle requirements as its packet size is small and the time taken to transmit the smallest packet is as small as 80 seconds. really consumes far less energy as compared to competing protocols such as ZigBee. The energy efficiency of Bluetooth Smart is 2.5 times better than the ZigBee. So the next protocol is ZigBee, which we are going to discuss here. ZigBee. ZigBee is based on the IEEE 802.15.4 communication protocol standard and is used for personal area networks. As we know that IEEE 802.15.4 standards has low power MAC and physical layers. The ZigBee was developed by ZigBee Alliances, which works for reliable, low energy and cheap communication solutions. The range of ZigBee device communication is very small. That is 10 to 100 meters. The details of the networks and application layers are also specified by the ZigBee standard. Unlike Bluetooth Smart, the network layer here provides for multi-hop routing. So, moving further, the next protocol is Sigfox. So what Sigfox is one more protocol that uses narrow band communication. That is 10 megahertz. It uses free sections of the radio spectrum, ISM band, to transmit its data instead of 4G networks. Sigfox focuses on using very long waves. Thus, the range can increase to 1,000 kilometers. Because of this, the energy for transmission is significantly lower than contemporary cell phones. But in this case, the cost is bent. It can only transmit 12 bytes per message, and the device is limited to 140 messages per day. Although this is reasonable for many kinds of applications, such as submarine applications, sending control codes, geolocation, monitoring remote locations, and medical applications. To avoid interference, the protocol hops across frequency bands. It supports cryptographic encryption and mobility. Is any message? Okay. The next protocol is Z-Wave. This is also a low power MAC protocol developed by Genesis. I will bind up in more than in 5 to 10 minutes. So please bear with me. That uses wireless home automation to connect 30 to 50 nodes and has been used for IoT communication, especially for smart home and small commercial domains. This technology is designed for small data packets at relatively low speeds up to 100 kbps and 13-meter point-to-point communication. Therefore, Z-Wave is suitable for small messages in IoT applications like light control, energy control, healthcare control. Z-Wave depends on two types of devices, controlling and slave. Slave nodes properties are low-cost devices unable to initiate messages. It can only reply and execute commands sent by controlling devices that initiate messages within the network. And the last technology which I am going to discuss is cellular. I am kept it is in last because almost all of us are familiar with cellular technology. This is a technology great fit for applications that need high throughput data and low power and power source of IoT applications that requires operations over longer distances. It can take the advantages of GSM, 3G, 4G, and in future 5G cellular communication capabilities. It can provide reliable high-speed connectivity to the internet. However, it needs high power consumption. Therefore, it is not suitable for M2M or local network communication. Cellular communication protocol is also used for many applications, especially for applications that involves mobile devices. And cellular topology depends on various technology. So now the concluding remark. As we have seen that six low-band, Zigbee, Bluetooth Smart, NFC, Z-Wave use the advanced encryption standards, block cipher with counter mode, while cellular and RFID use RC4. But there are several serious weaknesses in this. Advanced encryption standard is extremely secure, while RC4 is not. But RC4 is very quick compared to AES. So trade-off had to be made. Either you want extremely secure message or you want fast message, depending on the location of employment. Next is power consumption. Six low-band, Zigbee, Bluetooth Smart, Z-Wave, and NFC are designed for portable devices and limited battery power. Thus, it offers low power consumptions. While on the other hand, cellular high power consumption is in the list. In terms of data rate, 6LoWPAN, Zigbee, BLE, NFC, Sigfox, and Z-Wave have data rate is less than or equal to 1 Mbps. However, RFID has the highest data rate of 4 Mbps. In terms of range, Sigfox and cellular are range longer than the coverage of several kilometers. However, 6LoWPAN, Zigbee, Bluetooth Smart, NFC, Z-Wave, and RFID are range shorter than covers less than kilometer. Being IP-based wireless sensor network, 6LoWPAN protocol has edge over others. It allows a vast number of small devices to be deployed over the internet easily by using the huge address space of IPv6 for data and information gathering through features and behaviors of various metrics, including low bandwidth, different technologies, and star mesh, power consumptions, low cost, and scalable networks. That's all that I want to cover in this session. If you have any queries, you can send me at my mail ID or you can talk directly. I have given my email ID at the start of the slide, that is arun@reck.ac.in. And for preparing this lecture, for this session, the different references are taken. One is from my own paper, and other is important, that is Internet of Things. Second, Architecture, Protocols and Applications, Journal of Electrical and Computer Engineering, article number ID 9324035. It is one of the good articles which I found during the preparation of this talk on the network technologies and connectivity technologies.
हेलो जी सर, मैं 1 मिनट रुक के बात करता हूँ, मीटिंग में हूँ। ठीक, ओके।
I have just completed my talk. If you have any queries or any question, you can talk to me.
Thank you very much, sir. Participants are requested to put their question. If you want to ask a question, please raise your hand so that I can.
Otherwise, you can also send me at my email ID. I will definitely answer back to you.
I am audible to everyone.
Yes, yes, sir. Yes, sir. UP, sir, audible.
Yes, sir. Yes, sir. Yes, sir.
So please unmute your mic. If you want to put a question, please unmute your mic and ask.
Yes, sir, or better to give, better to share the mail ID of sir. So
I have already given it to, I think I will share it to 1 minute. I am giving it right now.
Yes, sir. Yes, sir.
Arun, you can note down arun@reck.ac.in.
Okay.
I will also share my PPTs to all of you. Otherwise, I will send it to the.
I request Dr. A.K. Singh sir to now please on your video. I am taking the screenshot. Please, sir.
Oh, okay. But okay, for this I have to stop my sharing. Okay. I think I am visible now.
Yes, sir. Visible. Yes, sir. UP, sir. UP, sir.
Yes, sir. Yes, sir. Other
Yes,
candidates
sir.
are actually on doing their video on. So let me take some screenshots.
Okay, okay. Please inform the session.
I am there, sir. Hello,
Yes.
I am audible.
Yes, yes. Definitely audible. You may ask. Please.
Okay, okay, thank you.
Thank you, everyone. I have taken some screenshot. I will share on WhatsApp. And now, Hari sir, please.
So finally, this is the time to conclude the session. This session was very interesting by Dr. A.K. Singh sir from Rajkiya Engineering College, Kannauj, and the talk was very much informative on IoT, networking and connectivity technologies with recent updates. So hopefully we have shared knowledge. And finally, thank you, sir, for such informative session, and thank you all these participants for patientful listening. So if you all allow, so kindly we conclude our session of this day. Tomorrow at 10:30, we will be reaching. Kindly log in at least before 5 minutes start of the session. So thank you everyone for patientful listening, and thank you once again Dr. A.K. Singh sir for such informative lecture.
Also, thanks to all
Thank
of
you,
you.
sir.
Including
I want to
UP Singh
I
ji
want
and
to request the attention of all the participants for today's session. We have already enabled the chat box. Today it was not enabled due to some technical problem, but from today's first session and onward in every session, chat box will be enabled, so everyone will be able to chat directly. Thank you very much.
Okay. Thank you.
may I leave, sir?
जैन सर नमस्कार। जैन सर
Yes, sir.
अनम्यूट करें सर। नमस्कार, ए के द्विवेदी मैथमेटिक्स वाले।
अरे सर 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 क्या हाल है?
बढ़िया है सर, और बताएं।
बस सर
भदोही में ही है ना?
नमस्कार।
नमस्कार नमस्कार।
द्विवेदी सर नमस्कार।
बहुत बढ़िया रहा, बहुत बढ़िया रहा।
यूपी सिंह सर।
सर
अरे एक्सीलेंट था फर्स्ट सेशन में, और सेकंड जो सेशन था टेक्निक, अरे मैं तो 1.5 घंटे से परेशान था। कहीं स्टूडियो बाहर जाके वाईफाई देख रहा था, कहीं अंदर जाके कहीं ऐप देख रहा था, मोबाइल पे कनेक्ट ही नहीं हो रहा था। अभी पीसी पे जाके कनेक्ट हुआ है।
आज सर प्रॉब्लम है rediffmail.com आज खुल ही नहीं रहा है।
आज थोड़ा सा क्लाउडी सीजन है, हमारे यहाँ तो नेटवर्क बहुत अच्छा था, लेकिन कई जगह पर नेटवर्क की दिक्कत थी, लेकिन लोग समझना नहीं चाहते।
नहीं, फर्स्ट सेशन में कोई प्रॉब्लम ही नहीं थी,
एक्चुअल में सर
राइट चल रहा था। ये सेकंड सेशन ही
आज सर rediffmail.com खुल ही नहीं रहा है।
हाँ, आज थोड़ा प्रॉब्लम थी, नेटवर्क में प्रॉब्लम थी, क्लाउडी सीजन होने के नाते।
नहीं सर, ये
बादल गिरे हैं ना।
आप लोगों ने जो ये प्रोग्राम ऑर्गेनाइज किया है वो
सर आपके द्वारा भेजी हुई मेल आज मेरी खुली ही नहीं।
अरे कोई बात नहीं सर, आप आ गए तो बस आने के लिए तो मेल भेजा।
आज जो है रेडी मेल खुल ही नहीं रहा है, कोई प्रॉब्लम है शायद टेक्निकल।